In physics, there are two special outstanding problems. One deals with gravity, the other deals with magnetic monopoles. Let me emphasize two things about these problems. First, Maxwell's equations of electromagnetics predict the existence of magnetic monopoles. In my opinion, magnetic monopoles do exist. Scientists have been trying to discover magnetic monopoles, to find them. Supposedly, nobody as yet has ever detected them. Second, scientists have also been trying to integrate gravity into Maxwell's equations of electromagnetics. For over 100 years, scientists have been trying to discover some way of combining electromagnetics and gravity. Supposedly, nobody, as yet, has ever directly combined gravity into Maxwell's equations. In my opinion, John Henry Poynting, in a way, did so about 100 years ago. When you start to think about these spherical waves, something remarkable happens. These spherical waves reveal something amazing. Elementary particles are magnetic monopoles. The field of a magnetic monopole is not actually some new, as yet undiscovered form of magnetism. It is simply gravity. If I am correct, then it is correct to say gravity is the monopole form of magnetism. Let me repeat that. Gravity is the monopole form of magnetism. The seemingly separate problems of discovering magnetic monopoles and integrating gravity into electromagnetics simply is the same problem. All particles of matter that you now see and feel all around us are magnetic monopoles. In essence, if I'm correct, the three fundamental forces are electric, magnetic, and gravitational. Together they form one unified field. While physicists have observed forces they call the strong nuclear and the weak nuclear forces, in my opinion, they are not fundamental forces. They are dependent upon and can be derived from the electric, magnetic, and gravitational forces. Remember what I said earlier about basic units and derived concepts. The same idea applies to forces. If the strong and weak nuclear forces can be described using electric, magnetic, and gravitational forces, then the strong and weak forces are not fundamental forces. Unfortunately, there's not enough time to give a further explanation in this science film. I'm planning a separate, short, dedicated science film on the strong and weak forces for later. I decided to call my definition of time the speed of light definition of time. It is an obvious name. I decided to call this grand unification theory the ball of light particle model. I agree it's not the greatest name, but it gets a lot of nods from the layperson. For most people, it is easy to visualize balls of light. In essence, the speed of light definition of time is an alternate to special relativity. In essence, the ball of light particle model is an alternate to general relativity. By itself, the Poynting vector is just an equation. It is not a grand unification theory. Using the speed of light definition of time, along with the Poynting vector, along with describing photons and elementary particles as spherical waves, is a grand unification theory. So, in a nutshell, that is it. In my opinion, this is what lies at the center of the physics labyrinth. John Henry Poynting developed the Poynting vector. Oliver Heaviside and others started work on electromagnetic mass. A very important detail is Poynting and Heaviside and other physicists of their time visualized elementary particles as having parts. They did not understand how the parts of an elementary particle could attract each other. They never understood that if the elementary particle is a spherical wave of fields, these fields could be self-confining. The fields in these spherical waves create their own self-confinement. Self-confinement explains why elementary particles like neutrinos, electrons, and protons are so stable. Personally, I believe what so confused the physicists of Poynting and Heaviside's time is they thought about hot plasmas too much. In a hot plasma, positively charged protons and negatively charged electrons could attract each other, but the heat keeps breaking their bonds. More importantly, each proton repels other protons, and each electron repels other electrons because their charge is identical. In a hot plasma, nothing wants to stick together. Everything wants to fly apart. This repulsion is what makes nuclear fusion so difficult. Their solution for modeling elementary particles was only to imagine smaller particles. In my opinion, that was the mistake. The smaller particles, the smaller parts, were just not there. Instead, elementary particles are made of spherical waves of fields. The physicists kept worrying about how can you overcome such powerful repulsive forces between the smaller particles. They thought if an elementary particle is made up of smaller particles, similar to the model for the atomic nucleus, and if these smaller particles are packed extremely close to each other, and if they repel each other, then what is the glue that holds everything together? Going back to the turtle joke, you can't have turtles all the way down. You can't just keep dreaming up smaller and smaller particles and smaller force carriers. What lies beneath is not some kind of smaller particle. What lies beneath are not geometrical manifolds of space in the form of vibrating strings. It is not turtles all the way down. Fundamentally, at the bottom, there are only fields. What lies beneath are the three fundamental fields, or you could call it the one unified field. While the repulsion between elementary particles with the same charge is very powerful, the electric, magnetic, and gravitational fields in a spherical wave can be strongly attractive. The gravitational portions of the fields attract each other. The electric portions of the fields can attract each other. The magnetic portions of the fields can attract each other. Combined in two spherical waves, the three fields create a powerfully strong attraction. Obviously, this graphic is messy. It is a good example of why vectors is not optimum. Anyhow, the physicists of Poynting and Heaviside time were unable to imagine how the parts of elementary particles could be self-attracting. Their experience with plasmas led them to believe the parts of the elementary particle would repel itself, and the particle would explode and its energy would dissipate. The mathematicians of our time are having the same problem with solitons. Mathematicians have been attacking this problem using geometrical manifolds. Again, in my opinion, this is missing the boat, because to be a physical explanation requires including the three fundamental fields, the unified field. So, to recap, Poynting and Heaviside almost unified physics, but they did not understand time. In my opinion, at the time, Einstein's work made time way too confusing for everyone. Relativity made everyone think that length contraction and mass dilation were occurring in some kind of fabric of space and time. Again, there is no fabric of space and time. If someone was holding that fabric before me, I would say, that is fabric, not space, not time. That fabric would be something physical in space. Understand, even Einstein admitted he did not understand time. Understand, even one of the most famous physicists of our time, Stephen Hawking, in his book, A Brief History of Time, admits he does not know what time is. In his famous book, after a few pages of describing what other people have thought about time, Hawking admitted this. In his own words, quote, "Someday, these answers may seem as obvious to us as the Earth orbiting the Sun, or perhaps as ridiculous as a tower of tortoises. Only time, whatever that may be, will tell." Unquote. All I can say about this is, do not follow a leader that is lost. Do not feel pity for Stephen Hawking. Do what is in your own best interest. I know what time is. There is no doubt about it. Now that we all have a basic understanding of time, hopefully we can move on. Physics is no longer stuck. When we use the speed of light definition of time, once again, space simply becomes an unchanging backdrop. With this new physics, the length contraction happens in the elementary particle. With this new physics, the mass dilation happens in the particle.